to I, side by side, currents flowing free.
Hello everyone, I hope all of you are doing well. So today we are going to talk about magnetic force between wires, and this is the topic for our lab for today. So let's start with the magnetic field created from a wire carrying current. So if we have a wire, that this wire carries a current I, then basically this wire creates some magnetic field around it. And the magnetic field of this wire, it's basically equal to P, magnetic field. It's equal to mu naught permeability in space, I the current, N number of wires that you have over 2 pi r. And the r is the perpendicular distance from the wire to the point itself. So let's say it is this distance. This is r. And the direction of the magnetic field, basically we use the right hand rule. We use your right hand, make the thumb point to the direction of the current movement, then curl your hand or close your fist, and by doing this you will see the direction of the electric field, the magnetic field, which basically is going in this direction. And this direction. So this is the magnetic field direction. Then let's go from the magnetic field to the force itself. So if you have some kind of magnetic field, let's say this is going to be the direction of the magnetic field. So this is B. And you put a wire inside this magnetic field and it has some kind of current. So we have a wire here, and this wire is carrying basically a current I, and the current is moving upward. So for this one, some force is going to be created on the wire, okay? And this force of the wire, it's basically equal to the force on this wire. It's basically equal to I, the length of the wire, multiplied by the value of the magnetic field that this wire is inside. And the force direction, it's basically use the right hand rule, the second right hand rule. So basically you make your fingers like this. This one would basically point to the direction of the current, and this finger basically direct to the magnetic field direction. So the middle finger is going to point to the force direction. So for our case, we are going to have current is going up, magnetic field is going like this way. So the force is going inside the board, okay? So there is some pulling force inside. Okay, let's say the direction of the force is going to be inside. So let's use this as an indication for the force itself. So the force, this kind of the back of the arrow, so it's going inside. So this is the force created. So from the force created on a current or a wire inside a magnetic field, let's see the force created between two wires. And both of them, they have current. So basically you have, this is a wire, this is another wire. Let's say this one is holds current 1 and this one I2, basically in this direction and in this direction. So there's some magnetic force created between these two wires. So to get the force of this one, basically it's as if one of them is creating magnetic field and the other one get the force itself. So if you consider, for example, that the magnetic field is going to be generated by I1, so P, okay, it's going to be basically mu naught, the permeability in space on the medium, multiplied by the current I1, multiplied by the number of wires over 2 pi r. And basically we said that the force of a wire on the wire inside the magnetic field, so let's imagine that we need to find the force exerted on the wire carrying I2. So basically on the wire I2, so basically this is equal to basically I2 L2 multiplied by B, and the B is generated from I1. Okay, so we have this one. Basically we substitute, so the force itself between the two wires becomes, or on this wire that carries the I2 from I1, it's basically I2 L2 mu naught I1 n over 2 pi r, and the r itself is the distance between the two wires. For the force itself, how is it? Basically, if these two, the currents inside, are moving in the same direction, that means they are attracted to one another. Okay? If they are opposite to one another, basically they repel. And we can check this basically by kind of finding the magnetic field here. So if this one is going up, then the magnetic field, basically it's pointing outside of the board. So we can say that this is the magnetic field, B1. And basically from the magnetic field I2, we can use the second right-hand rule, which basically doing our fingers like this, point the current is going up, then this is to the magnetic field, which basically in this direction, so the force is going here, which we see that the force in this case, it's pointing towards the other wire that carry I1. So the force is in this direction. So I hope you learned something today, and let's go for the lab itself. Thank you.
When currents run the same, they pull each other near.